Today, today we have an interesting invited guest speaker to talk about emerging technologies. And in a couple of minutes, I'll let him introduce himself. But before we do that, I just want to remind all the participants that this is the last live session. Starting today, you have 7 days to complete the course if you are seeking the certificate of completion. And remember the criteria you need to meet in order to get your certificate. We've sent a message yesterday to all the participants, so you're aware of what are those requirements. In case you've missed one, reach out to us if you have any concerns. Now, Lito is our guest speaker. He's from El Salvador, and he's well known. He's in the Hall of Fame of Internet Society as well. So he has been the founder of the Internet in his country, and he manages, if I recall correctly, the top-level domain for El Salvador. So, Lito, I'll hand it over to you so you can give more details of yourself. So the floor is yours, and thank you for accepting our invitation.
Thank you, Alfredo. Thank you, Glenn. Hello, everyone. Well, just to sum up what I've been doing for the last 30 or so years, I started into this, being an electrical engineer, I started into the internet thing stuff. Thanks to a workshop, I went to Costa Rica about TCP/IP, invited by OAS. And when I came back, I was sure I wanted my country to be part of internet. So I started to do all the necessary steps, like asking John Postel at that time. Of course, he was still alive. It's 1993. I asked him for the delegation of the top-level domain SV, and also for a block of IP addresses equivalent to the Class B, 65,000 IP addresses, in order to get our country connected to the internet. That happened in 1995, December 1995. So also I've been part of the board of several organizations in the ecosystem in my region, LAC, such as LAC-TLD, LACNIC, Red Clara, and ICANN worldwide, globally. So I had this honor and pleasure to be part of those boards. And of course, I'm also interested in internet governance. As a matter of fact, currently I am a member of the MAG, Multi-Stakeholder Advisory Group for UN. So we are very much involved in the IGF, global IGF, and regional and local IGF. So with that, I will start with the presentation. Okay, I've been meaning to talk to you about these topics. We will go over there and see what this buzz about emergent technologies, or emergent technologies can bring us, and why should we care about them? Why? Well, let me start with something I'm sure most of you know. 1969, we have this landing in the moon. We had the Woodstock Festival, for those of us who like music. Also, there was the last live concert by the Beatles in the rooftop in London. But there were also two events I want to bring your attention to. The first one, represented by this gentleman here, is the creation or the implementation of the microprocessor, meaning all the power of the CPU in computers was contained in a very, very small chip, And I consider that the start of the miniaturization of technology, which we all know is one of the most important characteristics nowadays of technology. And the other picture, as you may guess, is also September 1969 was the date of the first message, not email, but connection between a set of computers in the United States. So from that, was called ARPANET. We all know it turned into internet. Sorry. From that time, lots of things have happened. We all know there are a few names here that we all know, and it has not stopped evolving from that time. So, what is an emergent technology? So these are generally characterized by being innovative technologies that provide improvements over more traditional ones, but they have not yet reached their maximum level of maturity, which is why they are still in the process of development. For us, this would be the concept of emergent or emerging technologies. I will go through a few of these emergent technologies as examples, and then by the end of my talk, I will come back to how these are being integrated. And that integration, for me, is the main message of my presentation, but we will reach that at the end. Some of you will know a lot of about these technologies. Some of us will know less, but just this is a general overview of those. Starting with Internet of Things. By the way, there is no order, any order in these technologies as I present them. Well, this is the term was used in 1999 by Kevin Ashton, and he was trying to describe a physical world. I mean, objects that could be connected among them and with other computers and servers and stuff. So this technology helps us interact with stuff, like you can see in the drawing, like blower, kitchen, toaster, whatever. These are the most common examples used nowadays. But in reality, there are many professional and ways of working with IoT, and many enterprises, institutions, universities, etc., are already working with them, as we all know. For me, there are two ways of conceiving Internet of Things. One way is to see it as distributed intelligence. Why? Because we have many sensors, many actuators, many servers receiving data from IoT devices, processing them, and maybe taking decisions upon this information. So that's a way of, for me, that could be called distributed intelligence. We are acting, or humanity, or in several applications, we are acting on some signals or some values that we receive from parameters via or thanks to devices placed in several places. But from another perspective, it can be seen as a growing industry. There are many companies nowadays that they build IoT devices, sensors, actuators, motors, whatever, as we know, very small, so we can hide them or we can place them in several places, even outside in the environment, open environment, to learn about humidity, climate, winds, I don't know, many parameters, and take decisions upon those. But there are some challenges. There are many equipment, appliances, devices that will be carrying, are already carrying, but there will be more devices that will carry IoT sensors or actuators. And looking forward for our comfort, human comfort, maybe we will delegate some decisions to computers and devices, thanks to the readings of these sensors. But that brings some other challenges, such as security. We all know IoT devices are very small, and they have not enough hardware or resources to carry on, for instance, cybersecurity protection. So there are many vulnerable devices using IoT. So that is just one of the challenges. But although this, as other emerging technology, are very promising, we need to look out for the challenges, and this should be discussed in the Internet Governance Forum, because it's the place, unless we create another forum, but for the time being, these are the Internet Governance whole thing is the place for me to discuss these challenges. Another technology, of course, we all know, artificial intelligence, this year especially, has grown up in the popularity, if you will, of artificial intelligence, AI. But the term was coined in 1956 because it was very soon that after computers were created, relatively soon, people started to think, what about if the machines could do things, could imitate human cognitive functions? What would it take? So we all know about these experiments with Big Blue beating the world champion of chess, and that was a big thing at the moment, and of course it was. But the computer, the Big Blue machine built by IBM, was focused on playing chess. So it was, nowadays we could say that was relatively easy for that computer to do that, to beat the world champion of chess. But at that time, it was a big event, a big step. So like those, there have been many other AI events or machines that have been improving. And we come to the Turing test. Maybe you all know about Alan Turing. He created this test, or conceived this test, in which a human was speaking with somebody else in the other end, through chat, not necessarily with voice, but through a chat. And the goal of the test is to find out or manage to get the human believe he or she was speaking with another human. So that was in the beginning, that was not possible. But nowadays, people say that we have reached a point in the development of AI in which the Turing test may be approved, may be passed. That's maybe subject to debate, but still, the fact is that AI has come a long way since its beginning. It has many challenges. In the Internet Governance Forum, recent Global Internet Governance Forum in Kyoto, there were some sessions devoted to AI in some way or another. Even UNESCO has, and other institutions are preparing books or guidelines about ethics on the AI. So even I believe there are some countries that are trying to work on laws for the developers of AI applications. So there are some there can be some precautions in those applications. We have seen, I'm sure we all have seen many amazing stuff using AI. Usually they are for, in some cases for fun, in some other cases for preparing homeworks or other type of presentations or blogs or articles. And I would say most of them are still for good things, but there's no doubt AI can be used for performing or doing bad things, even crimes. So we need to be very aware of that implication from AI. And these are some of the ethical principles developed by UNESCO, and you can read them. And of course, there are more and more institutions that are developing the same thing. But still, the challenge is there, because as in other technologies, bad people or people that want to do bad things are not following laws or policies or good principles. So there is a challenge implicit in AI. Another technology is big data and analytics. This started in 2005. They're using the term big data. We all need to remember that at the beginning, the hardware to store data was expensive, and we, the ones we as myself that developed some applications at that time, were very concerned about the use of space, hardware space, be that in RAM or in hard drives or whatever, because that was expensive. That is no longer the case. We have access to many resources that can store thousands and thousands of data, and that is also seen from another side, that we ourselves, but some of the enterprises we interact with through the internet, they do have lots and lots of data about us, about our neighbors, about our people in general, different types of data. We all know about the social networks that store your preferences, your travels, your practices, or whatever. So that is a lot of data that can be processed, and some companies are already using big data and analytics in order to discover trends or patterns or anything that can help them, for instance, market in a better way their products or services. So, but that's another technology, if you will, that involves statistics and pattern recognition and so on. So that's another thing that is going on. And there are some challenges, again, that we can summarize in the 5 V's: volume, velocity, variety, veracity, and value. I guess we can more or less understand each of these challenges by the name, but there's a definition there. It's there are some challenges. There are some things and risks that how do we handle this large amount of data? How do we, from a good or positive standpoint, how do we make the best of this incredible amount of data in order to make a better product, a better service, or whatever we want to do with what we do daily. But again, there may be some bad uses. This has to do also with data privacy. What is the data belonging to me that I am entitled to take care of, other than the logical ones? I mean, address, telephone, and so on. But there are maybe another type of data that, for instance, the places I visit, my routines, my tastes in food or whatever. Maybe these are information I don't want to be public, but still this would be a challenge with big data. Another set of technologies, emergent technologies, if you will, is related to augmented reality, virtual reality, and extended reality. And we all know, maybe we know some of this from video games. In video games, there are lots of virtual reality creations, designs, and experiences that some of the gamers may feel through that. But this is coming, as we know, to another field, which is the normal, regular work. They are calling it immersive technologies, so we can see each other instead of like here, seeing each other in 2D dimensions in a screen. Maybe we can have holograms and other type of immersive experience in the professional area, not only in video games. Also, augmented reality, which is not the same, but we could say it related. We can also extract more from a real object by focusing in this area. We have the glasses from several companies that are developing this type of glasses. That when I see some people or some object, they will provide me more information about that person or that building or whatever as I wish. So these are possibilities of the virtual, augmented, or extended reality. This is another technology that it's been around, and it's emerging in the sense that more money, more resources, more time, more research and innovation are devoted to. Of course, there are many challenges. If we want some virtual reality or something like to be complete, we are missing the taste and smell senses, for instance. They're trying to reproduce the touch sense with gloves, using gloves. And of course, visual and audio are already there, almost there. And as I said, these are mainly used for now in video games. But as we will see in the end of the presentation, this will be more used in other environments. So that's part of the evolution we're seeing nowadays. Blockchain is another technology that has been around since 1991. And it's another way of storing data. Instead of a centralized database, a blockchain is a way to store data in a distributed way. So that's people that believe or use this technology, they ensure us that there are more security in this way of storing things, like using they use a group or servers that comprise a chain of blocks that store this data, and it's harder, if possible, to hack this information or to change whatever it is contained. So it's another technology we need to take a look at. We all know about the cryptocurrencies application of blockchain, but there are many more applications of this technology as a technology. For instance, such as intelligent contracts and other type of applications. There are some challenges. There is no single responsible entity to consult or complain to. So there are some risks that still need to be addressed. So, but this is another emerging technology. Digital manufacturing, known in some places as 3D printing, in general, again started in 1983, and maybe we have seen these 3D printers, and with the help of laser cutting tools and so some other stuff, we can build some prototypes or some versions of a device or a tool or maybe a spare part or whatever, using this digital manufacturing technology. We have even seen the printing, if you will, or the building of human organs in some applications, or even houses, small houses being built with this technology in some parts of the world. So it's another technology we need to take a look and be aware of the challenges. There are some challenges, some risk. For instance, materials used to print, as I said before, if we are going to print a human organ, of course, we are not going to use plastic or any type of those materials. And on the other hand, if we're going to build a spare part for a machine in an industry, we need to know if this part will be submitted to extreme heat or pressure or whatever. So we need to find out about this. But there is a technology there, and it is building up in our days. Robotics. We all know about robotics. We know robots has been used in industry, manufacturing of cars, appliances, devices, and so on. And they do good things because they are precise, they don't need to rest, and so on. We all know about this for a long time. And of course, this technology is also evolving in getting better every day, more accurate, more autonomous, if you will. But also, there are some challenges. For one thing, in the technology area, the artificial intelligence, materials, and energy sources, and so on, those are needs for their robots to stay working longer, I mean, energy and so on. But also, there are issues of costs and unemployment. That's a very still concerning thing about robots replacing human working for repetitive or dangerous tasks. And although that's the evolution of industry, we need also to take care of this and change, as we all know, change our professions, our works for the humans to come, and teach them things or activities that may take longer to be replaced by robots, or maybe never will be replaced by robots. That's another controversy being under discussion. Cybersecurity, again, is an area that demands lots of works, jobs throughout the world, because there are so many attacks, so many hacking, so many ransomware, and all of these threats that need to be taken care of. We don't want our credit card number to be stolen. We don't want our personal data or our accounts in different platforms to be stolen, and have somebody sending messages on our behalf and so on, or signing papers on our behalf and so on. So this needs to be, this is a never-ending run, because bad guys also know about technology, and we need to keep them up to date. Our servers, our data storage, and so on. There is, of course, some challenges that we are listing here, and that has to do with the constant evolution of technology that is used by cyber delinquents that we need to be protected from. Okay, that was a small list of emergent technologies that we face nowadays, that we can encounter and can learn about them. But the following step, I mean, the trend in our days, I have looked at three ways of integrating this technology. One of them is Industry 4.0, that is called. We're not going into the history of why it's called Industry 4.0, but nowadays it represents many technologies. You can see there another exhaustive list. We have talked about some of those. But the thing is that we, Industry 4.0 tries to include this or some of this technology in the manufacturing arena, in the industries, building anything. You can speak about building shoes, or making shoes, or making food, or whatever, and you can still have some of these technologies in the plant that produces that. But my reflection here is that despite the explosive and exponential development, entrepreneurs should not be overwhelmed by the large numbers of apparent needs. What I mean here is I have seen industrial people saying, okay, I want to be part of the Industry 4.0. So I will use all these technologies in my plants, in my factories, but there's no need for that. What we will need to do is each company, industrial company, must determine which technologies are applicable. They have to review if, for instance, IoT is good for them, or artificial intelligence may be used in this area of the factory of the company, or some other technologies will produce good results with enhanced productivity or quality in that specific good or service that this company is providing. Another way of integrating this technology is the metaverse. Metaverse is well, we have a definition here, which is very complex if you read it. I will read it. A massive interoperable network of 3D virtual worlds rendered in real time that can be experienced synchronously and persistently by an effectively unlimited number of users with a sense of individual presence and with continuity of data, such as identity, history, rights, object, communications, and payments. That is a definition in a book by Matthew Ball of the metaverse. If you go over the words contained in this definition, some of them have large and very important implications that are not here yet. Metaverse, as understood as this, is not here, and it will take some years yet to come. But for instance, for me, one of the immediate conclusions is that the digital gaps will be widening. I mean, if we, I remember I live in a country that is part of the developing world in El Salvador and Central America. We don't even have all our people connected yet to the internet. So with this, we need not only that people is connected, but very high speeds in order to get rendering in real time. That also implies large servers, large computers, very powerful computers. That means also security and also this persistent characteristic means there are some interoperability among the different providers of these services. It's like if we think about video games or Second Life type of experiences, you will need to, if you buy a hat, for instance, or a shirt in one of these virtual worlds, how do you do it to carry on that hat or that shirt to another virtual world made by another brand, another company? That is persistency. So there are so many challenges still for metaverse, but still that is another way of integrating this technology, because these terms, as I was saying, demand and expect for many of these technologies to be in place and working very nicely, having this rendering and reaction of virtual worlds in real time. So there are many challenges there. Web3, blockchain, and metaverse, and there are also these areas of for these technologies, emerging technologies to meet. So we need to be watchful on these developments because some people say, some authors say that these are the future of the internet. These are the next internet. That is the book that's in Spanish, but of course it's in English. In order to build a metaverse, we need networks, computing, engines of the virtual world, etc., etc. So that is still taking some time. The technologies need to continue their development on their own, but also they need to be working integrated in an integrated fashion. And the last one I wanted to mention is the spatial web. Spatial meaning in 3 dimensions. The authors of this concept, there's a book about spatial web written by Dan Mapes, and he is doing this through his company called Verses, and he's developing with his team a new protocol We will see that in a moment. But his aim and his team is to get us to a more similar web, more similar to reality, a way of communicating more similar to what we do in the real world, and that is a process ongoing that will need and will integrate many of these technologies. That is his evolution, his idea of evolution of spatial web. You see, they call it Web 3.0 or spatial web, and the hyper-spatial transfer protocol. The spatial, it hard for me to pronounce correctly in English, not special, but spatial, or I don't know if I am pronouncing it well, but in any case, there are so many technologies, as you can see here, AI, blockchain, augmented reality, and so on, that they will be using in this spatial web. Again, there are many technologies, digital twins, avatar. There are technologies and concepts that will be used in the spatial web. So I think this is another way of integrating all these emerging technologies. So finally, my conclusions. As we have seen, most emerging technologies have been around for several years. They are not really new, like last year or something like that, but they are becoming relevant due to the progress in their development, the emergence of more companies, and the growing number of connected users. It is possible to visualize the integration of several emerging technologies, creating even more specializations. We have seen here 3 of them: Industry 4.0, Metaverse, and a spatial web. Finally, the challenges that each of them poses to humanity caused us to expand discussions on internet governance. Some people say we need to call it digital governance, but in any case, this all happens over the internet using the protocols in the internet, and they still fall under the umbrella of internet governance. So we need to keep an eye on this evolution. We need to keep an eye on this integration of technologies, and we need to take care of whatever challenges arise from them. Thank you.
Great. Thank you so much. I'm so impressed with your presentation because it really gave a great summary or synopsis of all these technologies, but more importantly is how one has built on another, and the relevance. Even though we didn't have names for some of these technologies too much later, after the inception from some of the founders a lot further back than I even expected, but it was quite insightful. I'm going to open it up for questions, but if I can start with the first one, if you go back to slide 28, and it'll be helpful for everybody to know what I'm talking about.
I don't have the number here. Can you tell me which?
It's the one that talks about Industry 4.0.
Okay.
There we are. Okay, so I'm looking at this slide, and I see your graphic, which is fantastic because it's in Spanish. How does emergent or global economies in the South actually take advantage many of these technologies, which have been, financed, which have been adopted within the more richer countries? Is there a nascent or an indigenous economy that actually really can take advantage of this, or does many of these technologies, which are developed in the West, are basically exported? So rather than a producer of these technologies, more of a consumer. So it continues this sort of relationship, which I would say, quote unquote, a colonialism. So how does the global South become leaders in these technologies rather than just consumers?
Thank you, Glenn. That's a good question. I would say we in the developing world, or at least in our region, but I guess this could be happening in other parts of the world, in developing countries. We are struggling to have our young people learn about these technologies. We try to educate them in cybersecurity, Internet of Things, and so on. But again, we're doing this in an isolated way. I mean, like we teach mathematics and we teach, I don't know, dynamics or whatever. Maybe we teach them in isolated boxes, and then so they can learn about the principles and how to do digital manufacturing of these examples and so on. And on the other side, our industry leaders, they may go attend to fora, to work fora, and they listen that the modern companies are using some technologies in order to make more efficient their production line, or get more productivity, or enhance their quality of their products and services, but they don't know how to do it. So maybe they are still using old stuff. I don't know, that may be valid still, but what we need to do, what I think we need to develop some strategy, and that could be called a local strategy, or more regional or national strategy, is how do we get these young people that know about IoT, for instance, with the industrial guys that they don't know they need it because they don't see it where or how, and how do we get these two groups together? And more than that, how do we make possible that they see each other as collaborators, and they find common points of development or application of this specific technology? So if we manage to do this, or maybe we have to build new new initiatives, new entrepreneurs that they dedicate themselves to advise companies what technologies should they be doing. And once we are there, I'm sure, because it has happened in the past, I'm sure that they may come some specific or local developments of the industry, because we need another part, some other parts, some other materials, some other ideas, using the base technology that we are experts on, and build on that in order to make new applications. Maybe there are some products that are only harvested here in my country, or some products that need to be built here, and so on. So I think that's the way we should be doing. I'm not sure we are on that road. We are yet on that road, but I hope we can get there.
Great, thank you. One of the problems too is, like you said, even if you provide the education for the young people to actually take advantage of these technologies and offer their services, matchmaking with industry, but so many people, if they're the brightest and the smartest, they tend to be given fellowships or the scholarships. So there's a bit of a brain drain that happens in a lot of these countries. So the best and the brightest may be off to Oxford or Cornell or somewhere. They don't necessarily come back. So I'm not, we live in a society which allows the free flow of money and human resources. So, as soon as you clamp down on that, say you can't go, then you have a communist state. So it doesn't make any sense. So it's a real funny dance we have to do sometimes. I know that in Puerto Rico, there's the PRITC. It's the technology cluster, and which I've helped evaluate good proposals and worked with. So there's some models there that actually can work with, like the Chamber of Commerce, the technology groups, and the local IEEE chapters and stuff. This stuff, but you've got to get that local groups inspired and get charged up, and working with the local universities and basically sitting down with the government and saying, we need this local talent pool. We need these incubators to develop. And because I know Bill is on the line. He's deeply involved with a group that does training with INTC. Bill, do you have any comments on that? Do you follow what I'm saying?
I'm not sure I do follow it, actually. Give me try for a 2-sentence summary.
Okay, what I'm basically saying, because I know you do work with your boss in India with the IT training, and you're trying to develop local talent, and it's fundamental with more and more people with the IETF doing RFCs. So how do you see this issue? You got this emerging technology, but you need people on the ground doing this stuff and then matching up with industry. Is there something that you guys do at all from your experience?
Only to the extent that we do some training and occasionally take someone on board ourselves.
Mm.
We aren't really in a position to refer people to other organizations that are perhaps looking for trained talent. We do, as you say, do some training, and since it's done in coordination with organizations in India, we tend to leave getting people who aren't, who are students rather than already employed, to get them connected with various employers.
Okay.
But the reality is in IT generally that the demand exceeds supply.
No. Yeah.
Which has pretty much been the case for the last half century or so.
Yep.
We get occasional glitches for maybe a year or two when the economy totally tanks, but in general, you may not be able to find the perfect job at ridiculously large amounts of money, but finding a job at a living wage, in my observation, is the biggest challenge is if you don't know how to look for work. And if you're at a university, there is lots of help available for you to make that first step.
Okay. Is there, Bill, since I have you, is there, I focused on one area. Is there anything else you want to ask Lito or Ed?
Yes, I would like to add that these technologies and these young people that are learning about them, also they have another possibility. In my country, as in many other countries, we have a large numbers of immigration, or migration, if you will. We many people from here, from our countries, go to other countries in order to look for better jobs or better fortune and so on. But with these technologies, what we are saying to our young people now is that they may not even need to go away from our country, because thanks to the internet, they are able to work from here. For instance, developing applications or doing some designs of any things. So they can work in a team with some other people in other countries. So they are not in need to go from or leave our country. So that's I think a good thing, a new thing, if you will, that we have to educate our new generation that is being taught these technologies, that they may work for most of it maybe some small part is not possible, but most of it can go this way. And if they need to travel, which is okay, or maybe to move to another country, is because they are improving, they are getting more, pay more, or they are evolving in the industry and so on. But that's a possibility that they can start from our country, not having to leave it. Right.
Yeah, one of the good things that came out of the pandemic was that remote working became much more accepted. I think the people who do the remote working were already fine with it, but it concentrated the minds of managers and executives that they had to try this because they couldn't get people to work at all. And they discovered, oh, this not only gets a lot of work done acceptably, but it actually reduces their costs. So it's a big plus. Because that was a couple of years ago, I guess I don't perceive it as an emerging technology, but probably more of an exploding technology. It's getting more and more use, and I don't really see it getting any less. The biggest challenge I see with it is figuring out, when you have people working remotely all around the world, how do you find a time when everybody's awake to hold a meeting? I ran into this challenge myself. I mean, this meeting started for me at 6 a.m. So I had to get up at 5 to get here. I have another meeting coming up immediately after, which I'm actually going to have to leave for in a couple of minutes. And it will be that's a little better for me at 7, but there will be people in East Asia for whom it's the middle of the night. Right. And this is a challenge. I'm not sure there's a technical solution, but it's a challenge that has not yet been satisfactorily sorted out. And that is, I think, becoming the main reason to actually relocate is not because you can't work from anywhere, but because you need to be in a location east and west around the globe where you don't have to become sleep deprived in order to talk to the people you work with. But if you're fortunate, you're in a time zone where most of the people you need to talk to can get to you. Thank you.
Okay. That's great. Thank you, Bill. Lito, I appreciate your time today. I'm going to go through the slides in more detail. It's a lot to absorb. I really like the down memory lane and connecting the pieces. I think it's a seminal piece, and if we can have your permission to share it with future courses, that would be a seminal piece in our emerging technology section. And unfortunately, Alfredo had to be at an OMCOM meeting, but he's very familiar with your work, and he high praise from Alfredo, which is hard to get. But thank you again for your time. Looking forward to seeing you sometime, maybe at IGF or ICANN meeting. Is there any final comments, Lito?
No, just to thank you for inviting me. It's been a pleasure to share these ideas with all of you. So thank you.
Okay, great again. Thanks, everybody. That concludes the call, and thank you for joining.